Electrical licensing is important because it ensures safety and expertise when performing electrical work. Although licensing requirements can vary, the general agreement is that only licensed electricians should undertake electrical tasks. This is because electricity can be dangerous if not handled correctly. Licensing ensures electricians possess the necessary knowledge, skills, and experience to perform the job safely and effectively. There are several key benefits to electrical licensing. Firstly, safety. Licensed electricians have undergone rigorous training and testing. This ensures they comprehensively understand electrical codes and safety regulations. They are also required to stay updated on the latest industry standards and advancements. Secondly, quality assurance. Licensing necessitates that electricians demonstrate competence through examinations and ongoing education. This is important because it ensures that all electrical work meets a high standard of quality. Thirdly, accountability. Licensed electricians are held responsible for their work. Any faulty or dangerous work can result in liability for damages or injuries. Fourthly, consumer protection. Licensing helps protect homeowners and businesses from unqualified or fraudulent electricians. However, there are exceptions to licensing requirements. 1. Permits. In some areas, homeowners can obtain permits to perform specific electrical tasks themselves. This includes things like replacing light fixtures or switches. 2. Grandfathering. Electricians who were practicing before licensing requirements were put in place might be exempt from needing a license. 3. Small-scale projects. Some states might allow unlicensed individuals to do smaller electrical jobs. This could include tasks like installing ceiling fans or wiring outdoor lighting. Ultimately, hiring a licensed electrician is generally recommended for any electrical work. Licensing ensures electricians have the right qualifications to perform the job safely and effectively. It also protects consumers from unqualified or fraudulent individuals. Personal experience with electrical work doesn't automatically equate to the skill and expertise of a licensed electrician. While a person may have a working knowledge of electrical principles, licensing requires a complete understanding of electrical codes, safety regulations, and the best practices in the industry. The decision to hire a licensed electrician depends on the specific circumstances and the level of risk involved. For major electrical work or projects involving potential safety hazards, it's advisable to seek the services of a licensed professional. Electricians must have a comprehensive knowledge of the National Electrical Code, or NEC, which is regularly updated. The NEC contains guidelines and regulations that cover every aspect of electrical installations. Understanding the NEC is crucial for safe and compliant electrical work. Some examples of NEC requirements are as follows. Article 210. 8 covers ground fault circuit interrupter protection for personnel. Article 250 provides requirements for grounding and bonding. Article 300 describes the general requirements for wiring methods and materials. Article 310 provides ampacity tables for conductors. Article 408 covers switchboards and panel boards. And Article 547 details the requirements for agricultural buildings. An electrician must be familiar with conductor sizing and ampacity. The ampacity of a conductor is the maximum current, measured in amps, that it can carry continuously without exceeding its temperature rating. The NEC provides tables, such as Table 310.15b16, that list the ampacities of different conductors based on their size, insulation type, and installation conditions. Factors that influence ampacity include conductor material, which can be copper or aluminum, conductor size, which is measured in American wire gauge or AWG, insulation type such as THHN, THHW, or XHHW, ambient temperature, and the number of current carrying conductors in a raceway or cable. Correctly sizing conductors is crucial for safety. Undersized conductors can overheat, leading to insulation damage, fire hazards, and voltage drop. Voltage drop refers to the decrease in voltage along a conductor due to its impedance and the current flowing through it. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. Calculating voltage drop involves using Ohm's law on the conductor's resistance, length, and current. Grounding and bonding are critical for electrical safety. Grounding provides a low impedance path for fault current to return to the source, allowing overcurrent protection devices like circuit breakers or fuses to trip and clear the fault. Bonding ensures that all metal parts of an electrical system are electrically connected, minimizing voltage differences and reducing the risk of electric shock. The NEC specifies requirements for grounding electrodes, grounding conductors, and bonding jumpers. Ground fault circuit interrupters, or GFCIs, are life-saving devices that protect against electric shock. They monitor the current flowing in the hot and neutral conductors of a circuit. If there is a difference of 5 mA or more, the GFCI trips, quickly cutting off power to the circuit. GFCIs are required in locations where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters, or SIs, protect against fires caused by arcing faults. Arcing faults occur when electricity jumps between conductors or to ground, creating heat that can ignite surrounding materials. SIs detect these arcing faults and trip, interrupting the circuit and preventing a fire. SIs are typically required in bedrooms and other living areas. Overcurrent protection devices, such as circuit breakers and fuses, protect electrical circuits from overloads and short circuits. Circuit breakers are reusable devices that trip when the current exceeds their rated value. Fuses are one-time use devices that melt and open the circuit when the current exceeds their rated value. Selecting the correct overcurrent protection device is crucial. It must be sized to protect the conductors and equipment it serves, while also allowing for normal operation currents. The electrical panels, also known as load centers or distribution panels, distribute electricity from the main service to individual circuits throughout a building. They contain circuit breakers or fuses that protect each circuit from overloads and short circuits. Electrical panels must be properly sized to accommodate the anticipated load. They must also be installed in a safe and accessible location. Wiring methods refer to the different ways electrical conductors can be installed. Common wiring methods include conduit, which is a rigid or flexible metal or plastic tube used to protect conductors, cable, which consists of two or more conductors bundled together in a protective sheath, and wire, which is a single conductor, often insulated. The NEC specifies the allowable wiring methods for different applications. Electrical boxes are used to enclose wiring connections and protect them from damage. They come in various shapes and sizes to accommodate different types of devices and wiring configurations. Electrical boxes must be properly grounded and securely mounted. Electrical equipment, such as motors, transformers, and appliances, must be properly installed and maintained. This includes ensuring that they are properly grounded, adequately ventilated, and protected from overloads and short circuits. Regular inspections and maintenance can help prevent electrical problems and ensure safe operation. Working with electricity can be dangerous. It is important to follow safety precautions to avoid electric shock, burns, and other injuries. Always de-energize circuits before working on them. Use insulated tools and wear appropriate personal protective equipment, such as gloves and eye protection. If you are not comfortable working with electricity, hire a licensed electrician. Electrical safety is everyone's responsibility. By following safe practices and hiring qualified professionals, you can help prevent electrical accidents and ensure a safe electrical environment. In residential electrical systems, common voltages include 120 volts for lighting and small appliances and 240 volts for larger appliances like electric ranges, water heaters, and air conditioners. In commercial and industrial settings, common voltages include 208 volts, 277 volts, and 480 volts. These higher voltages are used to power large equipment and machinery. Three-phase power is commonly used in commercial and industrial settings. It consists of three alternating current waveforms that are offset by 120 electrical degrees. Three-phase power provides more efficient power delivery than single-phase power. Transformers are used to step up or step down voltage levels. Step-up transformers increase voltage, while step-down transformers decrease voltage. Transformers are used in a variety of applications, including power distribution, equipment isolation, and voltage regulation. Motors convert electrical energy into mechanical energy. They are used to power a wide range of equipment, from small appliances to large industrial machinery. Different types of motors are available for different applications, including alternating current motors, direct current motors, and universal motors. Lighting is an important aspect of electrical systems. Different types of lighting are available, including incandescent, fluorescent, LED, and high-intensity discharge lighting. Each type of lighting has its own advantages and disadvantages in terms of efficiency, light quality, and lifespan. Renewable energy sources, such as solar and wind power, are becoming increasingly popular. These sources can be used to generate electricity and reduce reliance on fossil fuels. Electrical systems that incorporate renewable energy sources must be designed and installed according to the NEC and other applicable codes and standards. Smart home technology is becoming increasingly common. Smart home devices can be used to control lighting, temperature, security, and other aspects of a home. These devices can be controlled remotely using a smartphone or other device. Electric vehicle charging stations are becoming more common as electric vehicles become more popular. These charging stations allow electric vehicles to be charged quickly and conveniently. Electrical systems that incorporate electric vehicle charging stations must be designed and installed according to the NEC and other applicable codes and standards. Troubleshooting electrical problems requires a systematic approach. Start by identifying the symptoms and gathering information. Then, use a multimeter or other testing equipment to diagnose the problem. Once the problem has been identified, you can repair or replace the faulty component. Electrical maintenance is important for ensuring the safe and reliable operation of electrical systems. Regular maintenance tasks include inspecting wiring, tightening connections, and testing overcurrent protection devices. Proper electrical design is essential for creating safe and efficient electrical systems. Electrical design involves calculating loads, selecting appropriate wiring methods, and ensuring that the system meets all applicable codes and standards. Electrical inspections are performed to ensure that electrical systems are installed and maintained according to code. Electrical inspectors check for safety hazards and code violations. Electrical permits are required for many types of electrical work. Electrical permits ensure that the work is performed by qualified individuals and that it meets all applicable codes and standards. Continuing education is important for electricians to stay up to date on the latest codes, standards, and technologies. Continuing education courses can help electricians improve their skills and knowledge. Being a licensed electrician requires more than just practical experience. It involves a deep understanding of electrical theory, codes, and safety practices. The licensing process ensures that electricians have the knowledge and skills necessary to perform electrical work safely and effectively.